My brother wants to buy this crusty old cat dozer. Supposedly it's been sitting for 5 years, which isn't really that long, but we don't know if it's really 5 years or air quotes 5 years. Apparently they used it to build this little bridge, and it hasn't been touched since. They're asking kind of a lot for what could easily be a bottomless money pit, so he wants to see it run before he commits. It's a D6D, which should be a mid-1980s machine. It's set up to pull a scraper. Apparently this plate welded on the blade is part of the scraper package. It's just a reinforcement so you can push against the back of another scraper. That's for running a scraper, that winch?
Only a scraper.
This winch is not really a winch. You can't really pull anything with it. It's a high-speed winch that's only used to control a pull-behind scraper. You don't really see cable-powered pull-behind scrapers anymore, and I would bet the scraper itself was scrapped long ago. But the machinery circle of life is always fascinating. Over the last 40 years or so, self-propelled scrapers kind of wiped out pull-behind scrapers. But now that's almost completely reversed. In our area, it's almost all pull-behind scrapers. But instead of dozers, they pull them around with big tractors, like big farm tractors.
I thought about bringing a generator and a charger, but I thought, well, we can't.
Got glow plugs. Overall, it looks pretty decent. The tracks and undercarriage have been replaced with all Cat parts. It has the original battery hold-down hardware, which is usually a very good indication that someone took care of it. We were wondering what we forgot that we were going to need.
Oh,
No vice grips for the battery terminal. The battery is junk, of course. It's a 1,000 amp, 24 volt battery. We didn't have an extra one of those laying around, so we hacked in two 12 volt batteries in series.
So do we want to kind of play with that throttle a little first?
Maybe.
I mean, you're going to turn it over a little bit before you even try to start it, right?
Oh, yeah. I haven't really thought that far ahead yet.
There it goes.
Now let me get the thing off the exhaust. That sounds like a motor. Do that throttle again.
What's that?
Do the throttle again. Okay, I guess. Is that on?
Yeah.
It's not moving very much. That's smoke coming out.
It's going to start.
Give her some glow plugs here.
Sounds pretty good cranking.
It sounds real good.
Like I said, I thought the thing would run. Well, just be ready to... Have we got an emergency shutdown in case it goes full throttle or anything?
No.
Take the pre-cleaner off, get some wood.
Probably got something.
You get pretty close.
Yeah, we got a oil brush, all kinds of oil brush.
Don't have 6 yet.
6.
It's running, but that's only half the battle. We can't just drive it out. It's winter, and the tracks are frozen to the ground.
On both sides?
That seems to work. It's kind of a slow process, but frozen tracks are no joke. That can cause a lot of damage. You could easily tear up a final drive or maybe even worse. Okay, it runs and drives. It sounds good, looks decent. It's not leaking everywhere. Yet, he's gonna buy it.
Yeah.
Okay, well, looks pretty good.
So let's see if I can find this.
This is my brother's Cat 304 mini excavator. Or maybe it's a MIDI excavator. I don't know what the cutoff is. I do know it's getting pretty sloppy, especially the bucket pivot. That's the one that always wears out first. It's down in the dirt all the time. It doesn't stand a chance. This one has a replaceable bushing, but the bore is so loose it just pops out or breaks.
Yep, didn't take much.
We gotta get the money shot here.
See how the outer part of this tube is mushroomed out?
Yeah.
That's what I think is really going on. It's not necessarily that it worn into it. It's just that it mushroomed from prying on it real bad.
Yep.
As it gets better as it goes in, but it's still pretty loose even in a way.
I don't think it's really worn in the traditional sense. It looks like the tube has actually stretched and bell-mouthed at the ends.
Is that it?
No, there's still a little on this side over here.
I think over there where you are, there's still another piece right here.
There's been a lot of bandages slapped on over the years. The typical process is to jam some kind of shim in beside the bushing and then burn it all together with a welder. That doesn't really work, as you might imagine. The bushings are hard and brittle like bearing races. They have to be fully supported by the bore, or things get crunchy. There's a few ways to fix this. We could make a whole new sleeve and weld it on. That sounds pretty easy, but I think we'd be opening a whole new can of worms. We could bore it out and press in a sleeve, but it seems like somebody already tried that. Didn't work out very well. The better way is to add some metal to the bore. I've got a tool for that. Then machine it back to the right diameter. You might not believe it, but I also have a tool for that. Oh, it hasn't gotten any lighter. This is my homemade portable line boring machine. I cobbled this together over a decade ago. It's powered by this ancient wrist snapper electric drill. Based on the flathead screws and the 3-letter Illinois abbreviation, I'd say it's at least 60 years old. And I'm sure it'll still be running long after I'm gone. This thing is an absolute unit. It had 2 more handles on it originally. I can't imagine anybody ever trying to use this thing by hand, but apparently it was possible. It moves back and forth on a little carriage. It was a linear stage that I salvaged from some kind of a packaging machine. It originally had a pneumatic cylinder, and I replaced it with a lead screw, and everything else I built from scratch. This is the actual boring bar. It's machined on the end to fit the drill chuck. It's got reamed cross holes for the cutters, which I just grind from some high-speed steel blanks. They dull pretty quickly, but it just takes a second to sharpen them on the grinder. The setup is actually pretty simple. You need a support bearing on either side of the thing you want to bore, and they have these brackets. Usually they just get welded right to the thing you're working on. The bar slides and rotates in the bearings. The power unit slips over one of the support bearings, and the drill grabs the boring bar. The cutter is installed, and away you go. The cutter spins and feeds through the bore, kind of like an inverted lathe. This machine doesn't have power feed, but you can fake it with a power drill.
It does work. It's a little rough around the edges, as I'm sure you'll see. You can buy a for-real line boring machine, but you kind of have two options. You can buy the name brand machines that are unbelievably expensive. Like you can spend 6 figures on a line boring setup without much trouble. Or you can take your chances with the raft of generic Chinese machines that have flooded the market. They all have the same problem. They're all geared towards big stuff, cutting edge engineering kind of stuff. And I mostly work on tractors and skid steers, and most of the things I want to line bore are in the 30 to 50 millimeter range. And most commercial machines are really set up for 60 millimeters plus. And they can do smaller bores, but you have to use awkward adapters and bushings, and they're not well suited for what I do. So I made my own.
This is a 50 millimeter bore, about 2 inches. Welding it by hand is challenging. MIG torches are pretty chunky. You can't reach, you can't see. Half of it's out of position. You have to be sure you weld enough, but if you weld too much, the bar won't fit.
They make automatic machines for welding up the bores, but they have the same problem as the boring machines. They're crazy expensive, or they're sketchy in Chinese, and they're all for doing larger diameters. I'd love to make my own for doing small diameters, but I've seen a lot of homemade line boring machines, and I've never seen a homemade bore welding machine. That's usually a sign that it's not a good idea. I guess. Let me know if that's something you'd like to see.
Spoiler alert, I already started.
That's not too bad.
Well, we didn't get very far. The bar jammed in the bearing, galled up, and would not come apart. I destroyed the bearings and really scarred up the bar. I made this thing from regular steel. In the US, it's called TGP, turned, ground, and polished. It really should be chrome plated, like a cylinder rod, or maybe even induction hardened and chrome plated, although I don't know how you would drill the cross holes. Luckily, it was fixable. We just needed some new bearings and several hours of vigorous shaft polishing. The actual boring is pretty straightforward. The only problem is the bar is way too long. It wants to whip around. I ended up adding the extra bearings just as kind of damper weights, and that worked pretty well. I've never worked on one of these machines before, so I don't know if there should be a shoulder for the bushing to press against, or if it just gets bored all the way through. I've seen them done both ways. Lacking any evidence to the contrary, we're just going to bore it straight through. That's a whole lot easier. We're almost to size, but there's a little spot that looks like it might not clean up. We're going to add a little more weld just to be safe. The final challenge with line boring is measuring. Normally you would measure the bore with a telescoping gauge, an ID mic, or a dial bore gauge, but you can't do that with the boring bar in the way, and you can't remove the boring bar or you have to take out the cutting tool and then you lose your position. Mostly what I use is this pair of spring calipers that I mutilated to fit around the bar. It works, it's kind of tedious, and you can't always trust it. I also have some attachments for my digital calipers that sort of work. The real machines use telescoping gauges that fit through the bar. I need to make something like that. Setting the tool is also a bit complicated. I just use a dial indicator, but you gotta be careful to get it just in the right spot. Somebody welded them too good. Got it. There we go.
This is just a porta pot? Same thing.
Oh, okay, now go.
If we did everything correctly, the bore should be right within a few microns. It's really kind of incredible that you can hit that kind of tolerance with what's basically just a crappy drill press. The bushings are exactly 50 millimeters diameter. The bore is about 49.9, just a little short. That should be about 4 thousandths press fit for the rest of us.
You see my mark? I can't see it anymore.
In my opinion, as long as you can press them in, you can't really make them too tight. The inside bore is usually quite a bit larger than it needs to be just for clearance for the grease, so you can really pack them in there.
Well, there you go.
That one pushed in a lot harder?
Once we got it straightened out, no, it was about the same.
Okay.
It was just when I was trying to pull it crooked there.
And this is because the face wasn't square?
Yep. Good enough for who it's for.
Okay.
Yep.
All right.
Pin needs to be replaced.
Yeah, needs a new pin.
And seals.
Pin and some seals. That one might be in a little too far.
It's okay.
You want to drive it back out a little bit?
No, I don't. Let's leave it. I don't know. I think that looks about right, honestly.
Okay.
It's fine. It's good.
Okay. Okay. It went together. That's all that matters. We need grease for it. It's got new bushings.
Probably just over greased the whole time, you know.
That's it. This place looks like a Mumbai shipbreaking yard, but that's nothing new. He needs seals, a new pin, and we'll have to weld some new bushings onto that coupler, and that should tighten it up pretty good for a while. I mean, the machine's got, I think he said, almost 7,000 hours. The whole thing's getting, pretty sloppy. It's the nature of the beast. They wear themselves out. You can slow it down, but you can't stop it. Anyway, I'm going to clean up and we'll do something else.